All right, welcome. I think we're now down to, I just counted, I need to count again, 6, 7, 8, 9, 10, 11. Okay, 11 people. That's about what we're getting these days. And hello to the viewers at home. I think people are actually watching the videos, so they're not a waste of time entirely. Let's talk about brain surgery.
Lionel, glad you could make it. Can I get you a drink?
Yeah, something soft. I'm driving. Parking's an absolute nightmare around here, isn't it? Had to reverse into the tiniest of spaces. Still, I managed it. I mean, parking's not exactly brain surgery, is it? And I should know.
Why is that? Are you a doctor?
Careful. Not a doctor. I'm a brain surgeon. Big difference. Big difference. Yeah, I actually know a joke about this. What's the difference between a doctor and a brain surgeon? One's not exactly brain surgery. The other is brain surgery. So, what do you guys do?
I'm an accountant.
Oh, that's good. Yeah, I could do with an accountant. Filling in those tax forms can get really confusing, can't it? Still, it's not exactly brain surgery, is it? I mean, brain surgery, believe me, is very complex. Are you an accountant too?
No, I work for a charity.
Oh, that's a very selfless job, isn't it? I really admire you. I don't think I could ever do what you do. I say that because it's emotionally draining, not because it's hard. I mean, it's not exactly brain surgery, is it? Which, as a brain surgeon, is what I do.
Lionel, here's your drink. Lionel's a brain surgeon, you know. Yeah, he mentioned it. Oh, Jeff, they keep you late at the Space Centre.
As always.
And this food round. Have you met Lionel?
No, hello, Lionel.
So, Jeff, how do you earn a crust?
Well, I'm a scientist. I work mainly with rockets. It's pretty tough work. What do you do?
Why, I don't mean to boast, but I'm a brain surgeon.
Brain surgery. Not exactly rocket science, is it?
I like the fact that the punchline is so obvious, you can see it a million miles away, but it still works. So, of course, the reason I'm showing you that, apart from that it amuses me, is that your previous homework, week back, did require some rocket science, right? You had to simulate the behaviour of a rocket. You're doing rocket science now. And it's a little bit difficult, and it did cause some problems. You might not have received your grade yet, incidentally. Valgrithar was, as I've said, was really busy last week. So she's in catch-up mode. What we've done is we've made her run ahead and mark the breakout exercises to get those up to date, and she's backfilling and is going through the spaceship one, so you should get your results for that fairly soon. And actually, to be honest, a lot of you did do fine in the spaceship exercise, but I know there are some subtleties in it, this whole thing about, the average velocity question, and maybe even the bit about setting up the sprites and the screen wrapping, which is not entirely obvious, especially if you didn't turn up to the tutorial, where I basically told you how to do it. So that being the case, this one is particularly worth doing a review of. So the first part of this lecture slot, I'm just going to review the spaceship thing and give you a bit more insight into how you should or could have done it, okay? So the spaceship exercise, I presented to you in two parts. The first one was just getting the basic sprite mechanic up, and then the second one was the more kind of physics or dynamics-based part. So if you go to the sprite part, it's not really that hard, but again, there are just some things you had to figure out. So here's how I did it, which is not the only way, but it's a fairly simple way I would recommend. So the first thing you had to do was fill in the constructor. So the thing you have to realise here is that the main job of a constructor is just to initialise the member variables of a thing, right? So now I didn't give you any content here, so you kind of look and think, well, what the hell am I supposed to do? And it's like, yeah, what does the constructor need to do? What do you want to know about the sprite? It seems to me, and there's a big clue in the parameter that I passed in, which of course I passed in for a reason, that really the main thing that a sprite needs to know in our current system is it just needs to know what image am I from. So the main thing is to do this, make sure that you just remember what image the sprite was, because if you don't have that, when somebody tells you to draw the sprite later on, you don't know what image you're supposed to draw because it doesn't tell you down here. The idea is that the job of the sprite is to remember what it looks like. So you make it remember the image. The other thing that I did as a convenience is that I just know, and you can see from the code, that later on I'm going to need to extract the width and the height of this image so that I can do correct centering. So I just pulled those out and made them member variables as well, so that the sprite sort of has an idea, like the sprite has got a width and a height, and yes, the image has one too. The distinction there would be if you had a sprite sheet, the sprite sheet might have like a very long image, like the ones I showed you with the running characters in it. So in that case, the width of the image might be like 500 pixels or something, but you might cut out a bunch of individual sprites, each of which would only be 32 or 64 pixels. So the sprite has kind of got its own width and height. And in those cases, in a general sprite system, it would also have a top left position that it would know how to extract itself from the sprite sheet. But because, in this case, our image only contains one sprite, we don't even need to do that. We just need to know what's your image and what's your size. So then the first thing you had to do was just the ability to draw a sprite centered on some coordinates, cx and cy, and with some rotation. And this is just basically a version of what we did with the generalized smiley, where we use canvas magic to, basically the hard part is to implement the rotation. And as ever, the trick with rotation is you translate the thing so that it's centered at the origin, then you rotate it, then you translate it back to where it's going to go. And because this is actually all done with matrix pipelines, it means the code kind of reads bottom to top, because it's this weird thing. You construct pipeline stages, click, 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 and then you shove the vertices up through them. Is how I think of it in my head. So that means that you draw the thing at the origin, then you rotate it, then you translate it to where you want it to be, and you wrap all this in a save and restore so that you don't screw up your matrix history. And that's it. There are easier and harder ways of doing this. I noticed that some people would they would draw the image at CXCY and then translate it, and then rotate and then translate it back. And that's actually fine because the matrix stuff compresses all down. But if you think about it, you don't really need to go and draw it here in order to then shift it up to here, or I should do that. Sometimes I mirror my gestures when I'm talking to you, and sometimes I don't. So top left is there, but I might occasionally say there because I can't always remember. I've got a lot in my mind. So rather than drawing the image at CXCY and then shifting it, I just draw it at the origin directly because I can, right? The draw image thing lets me draw it wherever I want. So in order to make it be drawn centered on the origin, I need to set the top left coordinates to be backspaced by half the width and half the height. And here again, I've just used a convenience like an abbreviation variable. I've said a few times, very small variable names are often kind of frowned upon as being, unclear, but we allow them for things like loop variables. And we also allow them for just very temporary shortcuts. So it's very easy. W obviously means width. The declaration is here. But the point is it allows these lines here to just be a little bit neater looking because I've used an abbreviation. So that's it. I just draw it at the centre, spin it, put it to where it's gone, and that's it. And that's how you draw a single copy of a sprite. Quite easy. The harder thing is how you draw the wraparound version of the sprite, which is this thing where if I move it and I take it over to the edges, it does that, or it does that, or even in the extreme case of the corner, it actually does all four. So those of you that attended the tutorial last week, I did basically tell you how to do this, but not everyone did, and I didn't record a video for it. So anyone who's watching now to try and catch up, this is where I give you the secret tip that you would have got if you turned up to the tutorial. So when it comes to the wrapping, there's a kind of obvious thing to do. The obvious thing is you detect the special cases. So you would detect when the x-coordinate was less than half the width of the sprite, which means that we're in this kind of danger zone here. And if you detect that that's the case, then you need to draw the sprite here and draw another one over here, which is 400 pixels away, 400 being the width. So it's basically, you would draw it normally, but if you detect that it's close to the left boundary, you have to say, and draw another one that's at the same coordinates, but the x plus canvas.width. And that's what makes the other one come out here. So you have an if statement that would do that. And you have an if statement on the other side, if the x-coordinate was too large, that would draw one at x-coordinate minus width to make it appear over here. This is really, because I'm having to do backwards here, but on the screen that I'm looking at, I have to do it the other way. Never mind. So you've got maybe two if statements to handle those two cases, and then another two to deal with the top and bottom overflows. And if you do all that, it will almost work, except it won't work at the corners. Because if you're at the corner, you would detect that, for example, this corner here, you would detect that, okay, he's falling off the left. So you would draw the ghost on the right, which would be this guy. It's like, okay. And then you would also detect that he was falling off the top. So your F for drawing the one at the bottom would kick in. But that's it. You'd only have 3 of them. You wouldn't have this 4th one. So now you have to add an extra bunch of code. In fact, what you would do is, the way to do it would be, you would check if both of your, if 2 of your conditionals have both occurred, then you have to do this 3rd thing. But it's really annoying that you have to write this like extra bit of logic to just make sure that the opposite corner always gets done. But that's basically classically how you would do this. And if you wrote some code that did that, and you did the if statements, and you managed to figure out the special case to get the 4th one, then that's great, and you get full marks. But there's a cleverer way of doing it, and the cleverer way is one of these strange things you get in computing, where sometimes the clever way is the dumb way. There's sometimes naive brute force actually turns out to be good. And I hate saying this, because I like complexity, but over the years I've also learned to appreciate simplicity. And sometimes the simple solution has got an elegance to it that it's easier to think about, it's obviously correct, it's like mentally less effort than doing the fancy thing, and it sometimes works better. I think there's a little bit of an analogy here to when you did the very first JavaScript homework exercise with the prime numbers and that whole thing about, square root without square root, where you just calculating square roots is hard, and you can spend a lot of time writing fancy square root approximator routines. Or you can just square everything, and that way you don't need square roots anymore. You just square both sides. Well, the analogous thing for ship wrapping, instead of having a whole bunch of conditionals working out whether to create left ghost, right ghost, top ghost, bottom ghost, diagonal ghost, just draw them all. Just draw them all the time. There are only 9 of them in total. There's one central ship, and you can imagine the ones that come out from it on the sides and the diagonals. The total, there are 9 that you might have to draw. And if you just draw them all the time, that'll work. They'll be there. And it's not like you have to draw an infinite number of them or anything. You just have to do 9. And as long as the initial ship is within the bounds of the screen, that'll solve it. So the obvious reaction to that, I would think, the first reaction is, ugh, that's ugly and stupid and inefficient, right? Well, is it? The thing is, when you draw those 9, like most of the time when he's here, if I draw 9 copies of this guy, one over here and one over here and one up and down, most of them, they don't hit the screen. That's okay. There's stuff, the computer has got stuff in it to detect when you're drawing things off screen. And once it works out the coordinates are off screen, it just doesn't draw them. And it has to do that all the time. Even if you've done all the fancy clipping logic yourself, once these draw commands, once draw image hits the graphics driver or some equivalent, it has to make sure that it's not drawing things off screen, usually. And it can basically realize that these things are off screen, and then it just doesn't draw them. Now, how does it do that? Well, it does an if statement. It does like a bounds check, right? But that bounds check is basically similar to the one that you would have had to have done in your code anyway, if you were doing the am I falling off left, am I falling off the right? So you're doing a bunch of if statements, and then under the hood, the graphics system is having to do those anyway. So you've actually made it worse. You've put ifs on top of ifs. If you do the dumb thing, you say, draw all 9 of them, and let the graphics driver reject the ones that are off screen, you've probably come out ahead, because instead of you doing a bunch of logic in JavaScript, which is a slow language, you will in fact fall down and get a bunch of clipping logic that's been written in a fast language, like C, that the graphics system is written in, and it will just reject them all. So it's kind of a big story to tell you a simple thing. The simple thing is you should just draw 9 of them. So the way I did this classically, when I first wrote this, is so you take the wrap center drawing routine, and what I make it do is I make it draw, instead of just drawing. So you could do this with a nested loop, 3x3 loop, but I decided to draw it as 3 columns. So it's like when you take this guy, I draw this one and the one above and the one below. So I write a routine for drawing columns, which is called draw vertical centered at, which just draws the main instance and the one at the above and the one below. So I've got like a column drawing routine, and then I call the column drawing routine 3 times, one for the middle, one for the left, one for the right. This is not like super beautiful or anything. It was just a way of doing it that came into my mind, and it's the one I've illustrated here. So this version I'm showing you, I've also added a little customization to it, where because I'm talking about these phantom ships that you can't see, I thought it'd be nice if you could see them. So I wrote a special zooming routine that lets you see what I'm actually doing, which which if I'll move them off here so you can see is a bit different, is this. Right? So that's what's actually happening. So when I draw this guy here, I'm actually drawing these clones all around him. So this is the blue area is the real screen, and the rest of it is I've used the scaling trick, so I've like zoomed out so that I've now got 3 times as much width and height, and you can see that I'm drawing these kind of clones down here, and you can kind of see how they interact there. And if I fly about, you can sort of see what happens. The clones just kind of pop in and out of existence just when they need to, with no special thought. It's just that the ships, the 3 main spaceships themselves, they keep wrapping around, so they remain within the central area. So you see them pop, he'll pop from there to there, and you see a little kind of echo of that. Like these ones at the edge, they don't wrap around the big universe, they just pop because the magic is happening inside here. So that's basically the system there, where you've got these clones all over the place. Now, actually, I was looking so I did it this way. Obviously, the other way is you can do a 3x3 loop. And actually, I looked at one of your submissions where someone had done the 3x3 loop, and they'd actually made it even cuter in a way that I liked. So I basically stole that idea, and I've created another version of it where instead of using my old technique here, I implemented the loop. The thing that's nice about this loop, this way here, which is doing the same thing, that's the one I'm using now, is that you can see how nice the loop looks. That's because it's using the var of facility. Now, var of is not something I've taught you. How many of you know about var of? At least a couple of hands, 3. Obviously, when you don't raise your hand, I don't know if it means you don't know or you just don't want to put your hand up. How many of you don't know about var of? Okay, 3, 4, 5. Okay, most of you don't know. Fine, great. So I don't mean to dwell on it, but var of is a nice little shortcut for iterating through collections that got added to JavaScript in the ES6 standard some years back. Now, I didn't teach this to you because for a couple of reasons. Remember, we only had 1 week for me to sort of teach you JavaScript, so I just taught you like the basics, and I kept to the things that are like analogous to Java and C. And also, I didn't teach you any ES6 stuff because the ES6 standard, when I first did all this, not all the browsers supported it. Like the old Internet Explorer didn't support these, and even the new browsers were a bit flaky, but they all support it now.
Also, all of JavaScript iterators don't guarantee order.
Yes. So there's also a problem with, as just in case you didn't hear Jan saying it, that there can be problems with correct ordering when you use iterators in JavaScript. There's a thing called var in that did exist in old JavaScript, and I told you not to use it. There's a way you can make a loop where you can say var something in, and it iterates through a container, but it iterates through it in a non-specified order, which is usually not what you want. But var of, if you make it iterate through an array, what it's doing here is it walks through an array, and instead of you having to have like a loop counter that goes 0, 1, 2, and then a bit in your loop where you index into the array to pull out element I, 0, 1, 2, it just pulls out the elements for you. So this is a way of just saying, I've got an array called W, and just go through it and pull out the elements and call them dx, one in turn. Now, I'm not trying to teach this to you now. I'm just letting you know that these facilities exist, and I deliberately chose not to teach them to you. But if you want to use them, if you know ES6, I will allow you to use it, but you do so at your own risk. It turns out there are subtleties with these things, like there's a thing about whether it will iterate through all the member variables that you add to an object. There's basically language subtlety stuff, right? So I just wanted you to know that if you're going to do stuff like this, do read up on it to make sure you use it correctly. But what I like about it is that normally I would have written this as a loop that had like for I equals 0 to 2, we go 0, 1, 2, and then we take I and multiply I by width to work out the x coordinate and add them on and do it that way. But this way what you do is you just set up a loop that's basically got the offsets that you want, which is the negative offset, 0 for the main guy, and the positive offset, and the same with the height. And then you just do this very simple piece of code that it basically tells you to step through these possibilities for the dx value, meaning delta x, and the dy value, meaning delta y, and you add them onto the center value, and it just does the whole thing very neatly in one line. So I just thought it was worth showing that to you as a little subtlety. Okay, so that's the wraparound part of the sprite. I can probably zoom back into normal scale here. All right, spritey stuff. So once you've got that done, then you need to do the spaceship logic. So the spaceship logic is not super hard, but as I say, there are these subtleties about particularly how to do the average velocity part, so I'll just show you that. Once you get into the meat, there's some other things on the way, like you had to do the compute gravity function, but that's easy, right? You just work out whether gravity is on, and if gravity is on, you return the specified gravity value, which I gave you, and if it's not, you return 0. And the idea is that there's a piece of logic here that computes gravity and adds it onto the acceleration, so that just either adds gravity or it doesn't. That's fine. The real work is in apply acceleration, which is where you compute your next position. And here's how I do it. So it's fairly simple. Again, I tend to remember the original velocity because I might want to restore it later on, and particularly in the case of like a collision. Sometimes when a collision occurs, you say, bail out, I want to set everything back to the way it was because I've made a mistake, kind of thing. And then you calculate what would be your new velocity, which is just, velocity acceleration times time, added, AT, exactly that, added onto u. So this is just the physics equations that we did, that Newton did. So you do that. Here's the important bit where you calculate the average velocity, which I kept trying to say was important. The idea is that on any given frame, of update, you have got an initial velocity and then forces are applied, which is going to change your velocity, so you get a final velocity that's something else. Initial velocity, final velocity. Now, if you imagine what happens during the time between those two, well, assuming the acceleration is a constant, which it often is for the kind of things that we're dealing with, the point is that during the frame, it'll actually use the average of the initial and final velocities. If you only use the initial velocity, you will actually get some slight errors, and that will cause your ships to diverge. The 3 ships that have got the different time steps, they'll diverge a bit unless you do this. So the important thing is you take the old velocity, which is the one you came in with, the new velocity, which will be the velocity on the next frame, and you work out the average of those. It's as if you've transitioned from the old to the new, and if you go from the old to the new, it's a bit like you were at the average all the way through. So that's what you do. Now I've actually got some conditional logic here where when I work out the velocity I'm using for the interval, I either use the average, which I recommend, or I don't. And the only reason I did that is so I can show you what it's like if you get this wrong. So the effect is real, but it's not huge. Whether the effect of averaging the velocities is large or not depends on the details. It depends on what your actual frame rate is. It depends on what your actual velocities and accelerations are. But if you take my reference example, and if I just start flying forward at kind of high thrust, you'll see that even though I'm going quite fast now, and I'm now flitting through quite a large amount of space, if I just press halt and I stop them, they're perfectly aligned, right? The ships did not drift away from each other, okay? Reset. If I press the V key, it toggles off the average velocity thing, and I go back to using the initial velocity, which is the naive thing that actually a lot of people do, right? Go back to that, and now if I thrust, it means that I'm actually not doing quite the right thing, and if I go for long enough, you see they start to drift apart, and then if I halt them to get a snapshot, you see that happens, right? So the ships do actually diverge. Now, not enough that you'd worry seriously about it, except unless you did, right? I mean, if you were doing this like in a network game or something, and you had different player ships, not showing up in the same place on different machines because they hadn't all been using the same delta time, you can see this could cause problems. I mean, eventually these ships will end up being a whole ship's width wrong relative to each other or more. And now things like collisions won't work. The server would think that they were colliding because it thinks they're all in a row, but on your local machine they're actually far enough apart that they're not colliding anymore. It can actually become really bad. There's one version of this that can even be practical. Like if you've got like a platform game and you're doing jumping, right? Well, when you jump in a platform game, that's just like falling under gravity, only the other way about. Well, it's both, right? You go up and then gravity comes in. If you run a standard naive gravity loop and you don't work out the average velocity, what will happen is the height that you reach will slightly depend on your frame rate. So somebody who's playing at 30 frames a second will reach a different height to somebody who's playing at 60 frames a second. So if you've got a platform game where you've got like a couple of pixel accurate jumps in it and stuff, you actually won't be able to make those jumps if you're not running at the right frame rate. So that's potentially, and it only takes, you only have to be off by 1 pixel, potentially, for that to be a problem. It could be game breaking, right? So it's small, but it could be critical. So just remember, if ever you're trying to do like a good physics system, the right thing to do is to work out the average velocity for your time interval so that things will actually remain in sync. So that's one thing I'm saying there. at the risk of making it even more complicated, there's another problem that you can get with this system, that even if you've got, so I'll just check that I'm back to average velocity so that these guys don't drift apart. Yep, that's good. Okay, halt. One thing you might have noticed, even if you wrote it correctly, if you fly around and you start thrusting as well, if you do it aggressively enough, and I'll have to amp this up a bit to make it happen, but if you thrust and you turn and you kind of go at it fairly hard and you do stuff like this, you'll see that eventually I've managed to make them diverge and they're not lined up with each other anymore, even though the code was right. So what happened there? Well, what happened there was, because I was thrusting and turning at the same time, it means that the ship that's only doing one update step, he will thrust and turn, or turn and thrust, whatever you write it, right? The one that's doing like the 4 baby steps, the problem is that he will thrust a little bit and turn a little bit, thrust a little bit, turn a little bit, thrust a little bit, turn. So actually 4 baby steps ends up not being the same as one big step because he's turning and thrusting at the same time, and that's why they diverge there. But I've got another trick. If I reset it and I press M, which toggles mixed mode, so there's a piece of code here in the ship update. Again, I did just to illustrate it for you. The update logic here, allow mixed actions. I've switched that off. So what I've done is I've set it so that you can't actually thrust and rotate at the same time. Now, normally you want to thrust and rotate at the same time in asteroids, but if I disable it, it will stop this little interference thing that occurs when the thrust gets broken up into too many substeps. So having done that, it should be the case now that if I fly around, even if I'm trying to turn while I'm thrusting, it won't let me. So now I have to stop thrusting and start turning and then thrust and then turn. And I can only do one thing at a time. And if I only do one thing at a time, the fact that I'm using the averages will mean that they actually stay in sync. So that's how that works. Just maybe press Q by mistake there, which will have reset the whole thing. That's rather annoying. I should take the Q key out. How any of you run into the annoyance of accidentally pressing Q and it terminates the game? Take it out. I'll try and take it out the next example if I remember. When I first wrote it, it was useful to have Q because it was a way of allowing you to, like, if you got into a kind of a game logic loop that wasn't behaving well, it was just a way of saying, quit the main loop. But in practice, it just means you can accidentally press it and your game goes dead for like non-obvious reasons. So I apologise, that was a miss feature. I should have taken it out. Okay, the other thing I can show you is, so we're back to like this is the good implementation. And if I switch, I'll put the trail on so you can see, oops, daisy, don't mean that. Right, put the, reset. What?
Trail on.
Oh yeah, good, right. Whew, I scared myself there. I thought I was running the wrong version of the multi-ships. So put the trail back on, put gravity on, and you get the gravity bounce. They nearly remain in sync, but they drift a little bit on the bounce as well. And it's the same thing. It's the baby step thing. Like if you take the one that's doing one big step, it will go from here to being out of bounds, and then you have to do the collision fix up. The one that's taking 4 baby steps, it might detect going out of bounds on the second of the 4 steps. So it'll detect the collision at a slightly earlier point in time, and it will respond to it slightly different because it hasn't gone as deep into the ground. So it'll actually detect the bounce at a slightly different point in time, and eventually that catches up with you, and that's why this guy gets into a little slightly different state to the other. So you do get slight divergences in gravity from the bounce, even when you implement it correctly. You could potentially work around this, but it would be a pain, so I didn't require you to do it. So that's the story there. Okay, so I think I've shown you the main part of the physics thing, which was the important thing, the averaging thing. The bounce thing, fairly simple. I just detect whether you've fallen off the world boundary, and then I use the old velocity before we'd computed the update, multiplied by minus 0.9, which is what I told you. It takes off 10%, and then you just bounce back up that way. So that's how that behaves. And I don't think there was anything else in there that was non-obvious. Well, maybe things like wrapping the positions. But it's not very hard. I just wrote a general wrap range thing. Actually, I think I made that a utility function somewhere.
Maybe it's good to mention that for the wraparound, you shouldn't...
You shouldn't clip.
No, you shouldn't teleport them, but you should minus the...
Yes, exactly. That's what I mean. Yeah, so the thing about the wrapping is, one thing to bear in mind is you could have said that, for wrapping, when the x-coordinate goes above 400 or something, set it to 0 to make it come in the other side. But you shouldn't do that, because it might have gone off to like 402, and it goes to 402, you need to wrap it around to 2 on the other side. If you just wrap it around to 0, you've actually pulled some velocity out of it. and that would also call your ships to diverge. Your 3 ships that are moving at different update steps. If you just reset them all to 0, they'll start to drift as a result of the wraparound. So the right way to do wraparound is to detect if you've exceeded the boundaries. I've written a general wrapper here for any min-max range, and it just means that if you, for example, if you exceed the max range, you just keep subtracting the difference between the max and the min. So basically, it's like modular arithmetic. In fact, it's very like modular arithmetic, right? So I just keep either adding or subtracting until it's within the safe range, and that way you don't lose velocity when you cross the screen boundaries. So any questions about that? I think that covers it quite well, and it was, in some ways a tricky exercise because you had to navigate my code, you had to figure out what I was thinking and kind of fill in the blanks. But I didn't want to give you, no support, so I gave you infrastructure that did quite a lot of the work. But that means you had to kind of figure out how to get into my headspace and to fill it all out. But the end result is, we're getting there. We've got the kind of core mechanics of a spaceship simulator. So I'll stop that part there.